Welcome to SQL Lesson 2. In this lecture, I'm going to be talking about scalar functions and two new clauses in the select statement. To stay oriented, here is the full select statement. Last week, we covered select and from. This week, we are going to add where and order by. We learned how to retrieve fields from a single table, select star from customers. Star in that context means select all fields from the table customers. We created calculated fields with simple arithmetic operations, plus, minus, multiplication, division. And we created user-friendly column names called aliases. In this example here, current price is an alias identified with the keyword as, and new price is an alias identified with the keyword as again here. Chapter 4 in your book discusses scalar functions. A scalar function is a rule for transforming input values to an output value. They're similar to functions in Excel like trim, and you will see some other functions that should look familiar to you. A scalar function goes row by row, so one value for each row is input and one value is output. We will review aggregate functions next week. Aggregate functions are functions like sum and average, where you would have multiple values as input and a single value as an output. But for now, scalar functions, row by row, one value in, one value out. Finally, there's a document on Moodle for common SQL scalar functions. You can refer to that as we go along, and we are going to practice some scalar functions after we cover the order by and where clauses. We're going to learn how to sort output. This is the topic of Chapter 5. We use the clause order by to sort output. Order by is always the last clause in the select statement. When we order by a field, we can order in ascending order, which is the default order, or we can order in descending order, which would be largest to smallest. If we want to order in descending order, we have to specify the keyword DESC. If we are ordering alphabetically or smallest to largest, we can either accept the default or specify the keyword ASC. When we specify multiple columns in the order by clause, the first column is always the primary sort. So you would sort everything by the first column, and then the second column sorted after the first column, and so forth. And in our examples, we'll look at the behavior of null values. So here are sorting examples. This is using the Rockoff schema if you're interested in following along in your database. In the first example, we're going to select the first name and last name from the salespeople table, and we're going to order by last name. So in this case, we've only specified the last name ordering, so it will order by the last name, and it will take whatever order the data is in the underlying database. That's what you'll see for the rest of the columns. If we want to order by last name and then first name within last name, so that would put Carla and Gregory in alphabetical order, then we would specify both last name and then first name in the order by clause. Here are a couple of more examples using the Rockoff schema. Ordering by last name in descending order, that gives us the last name here in the opposite order, so from Z to A. Another way we can order by first and last name would be to create a concatenated field. In this case, we're joining last name, comma, first name. We're naming that full name with our alias. and then we're ordering by full name. So that will also give us a fully alphabetized list, first and last name. This slide shows some details of how SQL sorts numeric and character data. This is our input table. You can see here we have character data. Our character data has numbers in it. They're numbers that are coded as character data, and here's a null value. And here's our numeric data, 2 positive numbers, a null value, and a negative number. So for the character data here, if we order by that field, the null value is always going to go first. And the way that character data is ordered, numbers will go before the letters. For numeric data, also the null will always go first, and then it will sort, of course, negative to positive numbers. Next, we're going to talk about the where clause. This is the material in Chapter 6. We use the where clause to select a subset of rows. In the select statement, select from our table list where, that's where we'll state our conditions, and order by. Where always follows the from clause. And one other thing I want to say is that the logic in the where clause can be simple or complex. We'll start out with some simple examples, and then after going over the material from Chapter 7, we'll practice writing some slightly more complex where clause statements. The basic syntax for the where clause is illustrated here. This is our sales table from the Rockoff database. In the first example, we're going to select the first name, last name, and quantity purchased. And here we're going to specify where the last name of our customer equals Carpenter. So notice we're using the single quotes here. Carpenter is a character data field, so we would use single quotes in the where clause. And that's going to output one row of data. We have one customer in our sales table who has the last name of Carpenter. In the second example, we're selecting where quantity purchased equals 5. Since this is a numeric value, we don't use single quotes. We would just say where quantity purchase equals 5, and we'll get the same row out here. This is a list of the where clause operators, and it includes some of the logical operators that are also covered in Chapter 7. A couple more examples using the sales table. Here we're selecting where last name is greater than K, so we're going to select everybody whose last name starts with a letter after the letter K in the alphabet. Here where quantity purchased is greater than 6, again, every row that has a value greater than 6 is going to be included in our output. I make a note here explicitly, single quotes for character data, no quotes for numeric data. MySQL is actually pretty forgiving. You will get answers even if you put quotes around your numeric data. So in general, we would use no quotes for numeric data and single quotes for character data. We're going to learn how to use the keyword like combined with wildcards to select character data using pattern matching. So we have 2 wildcards. The % wildcard means that we can use it to select any character, any number of characters. The underscore wildcard is a wildcard that means we are going to use it to match exactly one character. It can be any character, but only one character. And I'll illustrate what the differences are there with some examples. In the first example, we're going to look for movie titles that have the word love in the title. So we are going to write that as where movie title, like, there's our keyword, and then our wildcard %love %. So that means there can be none or many characters before the love. There can be none or many characters after the love. We're just looking for LOVE anywhere in the title. Our output, we have 2 movies that begin with love, so no characters before the L, doesn't matter. It could be 0, could be any number of them. Everyone says, I love you. There it is in the middle. And then down with love, again, no characters or any number of characters following the word love. Note that MySQL is not case sensitive using the like keyword. Here's another example. Now say we just want to restrict our list to movies that start with the word love. So in that case, we're not going to put that wild card in front of the letter L. We're just going to say LOVE, and then anything can come after that. So we'll get our 2 movies that start with love. Here, the list of movies that end with the word love, we'll put the wild card before love and nothing after it. That means that the title of the movie has to end in LOVE, and here's our example where that is true. The underscore wildcard again means exactly 1 character. So we're going to say, let's find our actors whose first name is like blank ARY. That means we're going to fill that blank in with exactly 1 character. So that could be Carrie, Mary, Gary, 1 character. Those are the names we're searching for with the underscore wildcard. This example is not used as much as the % wildcard. There are situations where you might be looking for cases where you only want to have a wildcard for a single character. Generally, we're going to be searching using the % wildcard. There's one other way to select a subset of records, and after this lesson, we're going to use it to limit the output. Just so that if you have long tables, especially in the classic car models and our homework, we can use this limit keyword and it will just restrict the number of rows output. So the limit keyword always goes last. If we had an order by statement, it would go after the order by. And you can see here, limit 1, we're telling it create the output, but just show us the first row. The keyword is top in Microsoft SQL Server and Access. You might be familiar with that from Access. And again, I will, in a couple of homework assignments, I'll start asking you to just limit your output to the first 5 rows, and it will be using this limit keyword. Boolean logic in Chapter 7. Those are the keywords that will let us write more complex logical expressions in our where statement. We will use and to combine conditions. When we use and, that means we want all of our conditions to be true. We can use or to combine conditions. That's going to be where any are true. The order of operations is important and is evaluated first if you have a logical expression that includes both and or is evaluated next. My recommendation is to always use parentheses to specify the desired order of operations, and I'll show you some examples where it matters. We use the keyword not to select the negation of conditions. Here is a list of other operators and functions that are commonly used in the where clause. In is shorthand when you're looking for matches in a list. Between is shorthand when you are matching a range. Say you're looking for something greater than or equal to X and less than or equal to Y. is null is used to find null values, and is not null is used to find non-null values. So we'll go through some examples of each of those. An example with in. Say we want to get a list of purchases from customers in California or Illinois. So first of all, I want to note that we're always going to use the 2-letter postal codes, and whenever I ask a question in your homework or on a quiz, I will always give you the 2-letter postal code. So in this case, California is CA and Illinois is IL. Here is our where statement using in. So we say in, and then we can just write the list here. It's character data, so we're using single quotes. And we could have any number of states in this list. It's a convenient shorthand. Otherwise, we would be writing something like where state equals California, or state equals Illinois, or state equals, so on and so forth if we had more items in our list. So here is the output. We're getting 2 customers out of the purchases table, one from Illinois and one from California. Here is an example with between. Our question is, get a list of purchases with quantity purchased from 5 to 20. So we'll select the customer name, the state, the quantity purchased from our table purchases, and here's our where clause, quantity purchased between 5 and 20. Between always goes with the keyword and here. And also it's clear in this example, we have James Carpenter, who has a quantity purchase of 5. Between is always inclusive. So it's always going to be equivalent to greater than or equal to the first number and less than or equal to the second number. So an example with dates. First of all, note that this is the format we use for dates in MySQL. The 4-digit year, 2-digit month, and 2-digit days with the single quotes for the delimiter. This is the returns table from Rockoff. So our question is, get a list of items that were returned after September 15th, 2016. So we're going to select all fields from the returns table, and here we're going to write this as return date greater than 2016-09-15. And you see we have one result, the return on September 28th. Some examples with nulls. Say we want to get a list of equipment. This is using the products table with null or 0 weights. So we have a where clause where we specify weight equals 0 or weight is null. So just note printer A has a null weight, printer B has a 0 weight. If we had picked just null, we would have gotten this one, and if we had picked the weight equals 0, we would have gotten this one. So we might write a statement like this where we want to find all of the rows where we think that there's a problem with the weight, right? We don't think that printer B really weighs 0, and so this would be a way to make sure we were finding all of the anomalies, looking for something where the weight is 0 or the weight is null. In the second example, we're looking for equipment that excludes records with null values. So this is an example of where we would use is not null. So we're selecting where weight is not null. Again, this will include our 0 weight, even though that's nonsensical. That's the way the data was entered. So printer B, 0 weight, and then the other 2 pieces of equipment there. Here's an example with complex logic. Using the purchases table, get a list of customers from either the state of Illinois or California who made purchases with a quantity greater than 8. So writing these complex conditions using in and between is going to help a little bit. So I always encourage you, if you're looking for a list of values, always use the in keyword, or if you're looking for something in a range, always try to use the between keyword. In this case, where state is in our list here of Illinois, California, and the quantity purchased is greater than 8. So we're getting one result here, Carol White, with a quantity purchased equal to 10. You can try this out on your own, but you're going to get the wrong answer if you just wrote this out all as one statement without any parentheses, where state equals Illinois or state equals California and quantity purchased equals 8. So the way this is going to be evaluated is that this and clause is going to be evaluated first. So you'll get state equals California and purchase quantity purchase greater than 8. That will go together. And then you will get anyone in the state of Illinois. So if you're writing your where clause out using this longer form of looking for states connected by the or clause, you'll have to use parentheses in order to get that logic to be evaluated in the order that you want it to. So in the final section of this tutorial, we're going to practice with more complicated data, the classic model schema. So if you are following along or you want to get connected to the database and follow along, get connected to the classic model schema. You need to double click to make sure that is bold over on the navigator pane. So if you're connected to classic model schema, the name classic models will be bolded, and then you'll be able to write SQL code for those tables. So this is where we're going in this next section. All of these practice problems are going to use the orders table. Here is a screenshot of the first 5 rows of the orders table. Order number, order date, required date, ship date, status, comments with some null values, and customer number. So these are the 4 questions we're going to address here in our practice queries, and we'll do this page by page. In the first question, show a list of all orders that do not have a shipped status. So what the key piece of information we need here to interpret this into a query is that we know that we're looking for everything where the status is not equal to shipped. So remember, this is how we specify does not equal to. So if you need to be reminded about this, it's on the list of the where clause operators. So our SQL code, select star. I didn't specify any column or specific fields to extract, so extracting all of them is fine. From orders, and here where status is not equal to shipped. So we have records with status equaled resolved, status equaled canceled, and so forth. In question 2, show the order number, the order date, the ship date, and number of days between the order and ship date for all orders that have a ship status. So you can refer back to the handout on SQL functions posted in Moodle to remind yourself date diff. This date function here is how we get the number of days between 2 dates. So we know we want the difference between ship date and order date. And then we're going to use that status now equal to shipped in our where clause. So select order number, order date, ship date. Here's that date difference clause typed out in the SQL query. I gave it an alias as days to ship from orders, and then here in my where clause where status equals shipped. So this is the output that I get. Question 3, show all orders for customer numbers 363, 121, and 141 that were required after January 1st, 2004. And here I say sort by order date. A couple of things to note before you jump into writing the code. We're going to use the where clause to select the list of customers and required dates after 2004-01-01. And we're going to use the order by clause to sort by order date. So first of all, our customers that we're selecting here in the where clause, I use, again, the in keyword 363-121-141. In our database, our customer, all of our primary keys that are numbers, they're actually numbers in the database. In some databases, these would be entered as character values. Again, SQL is pretty, or MySQL is pretty forgiving. In MySQL, you could have put character, those quote marks around these numbers, and it still would have worked. But the underlying data is numeric data, so you can just go ahead and specify the customer numbers as actual numbers. And then we're combining that condition with the required date being greater than January 1st, 2004. And we're ordering here by order date. So here is our output. It turns out, well, actually, this is just a screenshot from the first few rows. All customers 141 here, and then just eyeballing the required dates. We want to make sure that that worked. Everything's greater than January 1st, 2004, and it is. So that all looks good. In our final example, we're going to show all orders for customer number 141 that have a null value for ship date. So we'll use the isNull function to find records with null values. In this case, select star from orders where customer number equals 141 and ship date is null. So our output here, ship date has null values here. Here's our customer number 141. In your homework number 2, you're going to be using the Classic Models database. You're going to be getting lots of practice applying selection criteria in the where clause. And one thing I want to point out, I will be asking you to order your output in both ascending and descending order in many of your problems, so you make sure you follow the directions for sorting.